All right, here is your DeltaMath help for the assignment 1.13, identifying and removing discontinuities. I'm just going to go through a couple of the problems and help you make sure your notation is correct for them. So let's get started. All right, for this first one, it just looks like it's multiple choice. So you're basically just determining whether or not your function is continuous at 2 or not. And to do that, we have to check our 3 steps. So the first thing I'm going to do is I'm going to go ahead and I'm going to plug into oops, excuse me, -2. Oh, no, it just wants me to actually find it at 2. Okay. So f of 2, let's see, for all values, if I was actually going to plug into which piece of this equation would I plug it into? Well, I would actually plug it into the top piece because I'm plugging in an x value that's greater than -2. So if I do that, I would end up with 2 plus 3 times 2 squared, which would give me 2 plus 12, 14, right? 4, 3, yeah, okay. And then if I'm finding my left and my right hand limits of f of x as x approaches 2 from the left hand side and then the right hand side, well, from the left hand side, if I'm approaching 2 from the left hand side, I'm still plugging in numbers really close to 2, like 1.99, 1.999, and those are greater than -2, so it would still be me plugging in 2 into here. And then if I was plugging in values like 2.01, 2.001, because those are a little bit greater than 2, I would still be using the top piece of this equation. So that would be my right-hand limit as well. And then because my general limit, which is 14, equals my function at 2, I would say f of x is continuous at 2. Hooray! And like I said, it goes through and it kind of talks about it's not one of our breaking points, and so we tested the left-hand limit, the right-hand limit, and we got the actual function. All right, let's try one more. Oh yeah, I wanted to try one where we're actually testing at the breaking point. So let me go ahead and erase what I have currently. All right, so this one, we're going to do the same thing where we're going to find f of 3 first. So when I actually plug in 3, I'm plugging into the bottom piece. So I get -18 minus 2 times 3. So -18 minus 6 more would give me -24. Then I'm finding my left-hand limits and my right-hand limits. So my left-hand limit, if I plug 3, I would be using the top part because that's for values less than 3. So 3 minus 3 times 3 squared. So 3 squared is 9, 9 times 3 is 27, 3 minus 27 is indeed -24. And then my right-hand limit would be if I used the same piece that I'd use to actually just plug in 3. So my right-hand limit is also going to be -18 minus 2 times 3, which is -24, continuous. Oops. Lovely. All right, let's go back and try. All right, so sorry, I just had some weird editing stuff happen with the video. Don't pay attention to anything that's happening. Okay, so we're doing another type of problem here. All right, so in this problem, what we are going to do is we are going to find all values of k that would make this function continuous at x equals 5. All right, so basically the goal is that we would like to set the two values equal to each other, right? We want everything to be equal. So if I do, whoops, let me parentheses, x squared plus 6x minus 7 over x squared plus 2x minus 35 equal to k. And I want this to be true when x is equal to 5. The problem is, I think if I plug in 5 right now, I'd get 25 plus 30 minus 7 up top. And then on the bottom, I'd get 25 plus 10 minus 35. Yep, just what I thought. We end up with basically, on top we would have, what's that? Negative 25, 55 minus 7. Ooh, geez, that would be what, 48? Yeah, 48 on top. And then you would get 25 plus 10 is 35 minus 35, 0 on the bottom. So even if I tried to factor this, so like if I go ahead and I went back and I tried to factor this instead, I'd end up with x plus 7, x minus 1, and then x plus 7, x minus 5. even if I factored it and I could cancel on this side, and you can do that in this piece because we're finding the limit, even if I factor it, if I try to plug in 5 again here, I still end up with an undefined answer, right? So there is actually no value of k that would make this continuous. So I'm just going to go ahead and submit my empty set. Yepers. So then now they went through and they explained that no matter what, it's just everything's going to fall apart, right? So cool. All right, let's try another problem. Hopefully this one will work. So if we have, let's see, in this one, we want to make it continuous and the breaking point is at 3. So I'm going to set those things equal to each other. Kx squared, oops, equals kx. That's how you make an x, plus 18. But I want this to be happening at my breaking point of 3. So I'm going to go ahead and plug in 3 for x. So I'd end up with 9k equals 3k plus 18. Oh, I said 3k, and that's definitely not a 3k. 3k plus 18. There we go. So 6k equals 18, which means k equals 3. So that would be the k value that would make this function continuous because it makes everything equal at the breaking point. Woohoo! All right, let's try one more of these. That first one was tricky. All right, for this one, let's see, we want, again, the same thing to happen. We want kx squared to equal kx plus 4, but we want that to happen at my breaking point of 2. So I'd end up with 4k equals 2k plus 4. And so then you get 2k equals 4, so k equals 2. Oh, these just get easier and easier, huh? Awesome. All right, we did it. Let me know if you have questions on that assignment at all.